And the last one. We say a function has derivatives of all order at x equals 0. So this time when we're looking at the Taylor polynomial, a is 0. Let p n of x denote the nth degree Taylor polynomial for f about x equals 0. So I'm given f of 0, and I'm giving that p1 of 1/2 is -3. We're supposed to show that f prime of 0 equals 2. Alright, so what is p1 of x? That's going to equal f of a plus f prime of a times x. So p1 of x, we know that that's going to be this number, -4, plus f prime of a times x. So if we're looking at p1 of 1/2, then I have -4 plus f prime of a times 1/2, and you're told that that's equal to -3. So I have one equation and one unknown. So if I add 4 to both sides, f prime of a is 1/2. So this is 1. And remember, a is 0, so f prime of 0 is going to equal 2. Okay, quick jump up to go and turn the lights off. And I'm back. So, continuing on, now we're given that f double prime of 0 is -2/3, and f triple prime of 0 equals 1/3, and we're asked to find p3 of x. This is super easy. So, we know that p3 of x is going to have the terms f of 0 plus f prime of 0, x plus f double prime of 0, excuse me, x squared, plus f triple prime of 0, x cubed. So p3 of x, we learned from above that this is -4. And in the last problem, we learned that f prime of 0 is 2. And we were just given that f double prime of 0 is -2/3. Oh, this is supposed to be over 2, and this is over 3 factorial. 2 factorial, 3 factorial. Excuse my mistake. X squared over 2 factorial. And then finally we have plus 1/3 x cubed over 3 factorial. And simplifying one more step, we get -4 plus 2x. This will drop it down, and the 2's will cancel. So that cancels that. So I have a -1/3 x squared. This will drop down, and this is worth 6. So this comes down 3 times 6. So this will become plus 1/18 x cubed. So there's p3 of x. Question 3. The function h has his first derivative h prime of x, which is equal to f of 2x. It is known that h of 0 is 7. Find a third degree Taylor polynomial for h. So this is what we're going to do. We're first going to find this. So we're going to take our function, and we're going to replace each and every x with 2x. Then we're going to integrate this to get h of x. Then we're going to let x equals 0. H of 0 is 7, and we'll use that to solve for our constant. Alright, so h prime of x is f of 2x. So we can take this polynomial from above, and we only need the third degree. So that means we really can stop here, because when I integrate, this is going to go to 3. So this becomes -4 plus 2 times 2x minus 1/3 2x squared. That's equal to -4 plus 4x minus 4/3 x squared. So to get an equation for h of x, we are going to integrate h prime of x. So we're going to integrate term by term, minus 4 plus 4x minus 4/3 x squared dx. H of x is going to equal, raise the power, divide by it, minus 4x plus 4x squared over 2 minus 4x cubed over 3, and there was already a 3, plus c. So h of x is equal to minus 4x plus 2x squared minus 4 over 9x cubed plus c. We were asked for third degree. We have a third degree. Now we're going to use our initial condition. H of 0 equals 7, or 0, 7. So 7 is equal to h of 0. So that means anywhere where there's a x, put a 0. So we get 0 plus 0 minus 0 plus c. So from that we conclude c is 7. So our final full credit answer is h of x equals, I'm going to put the 7 first, 7 minus 4x plus 2x squared minus 4/9 x cubed. So that ends this video. Thank you.